going to learn about an amazing engineering and medicine collaboration called the M4 Lab. The 4 M's stand for medical, modeling, materials, and manufacturing. It is one of the first residents of Ohio State's spectacular Pelotonia Research Center on West Campus. The engineers, physicians, and students that work there leverage the power of additive manufacturing, better known as 3D printing, to improve and, in some cases, save lives. Today, I'm joined by M4 Lab Director Megan Malara, who is also a proud Ohio State engineering alumna. Hi, Megan. I'm tempted to call you M2 or M squared. Joke, joke, joke. You're supposed to laugh. I'll stick with Megan. Okay, Megan, I'm so glad you're here.
Thank you for having me. My full initials are actually M3, so I think there must have been some fate that landed me here in this lab.
Oh, that's amazing. All right, so let's go on this M theme. So at Ohio State, a top-ranked engineering college and a world-class medical center are on the same campus. Literally less than a 10-minute walk between the two. So it should come as no surprise that engineers collaborate every day with physicians, nurses, therapists, and medical researchers. But if there is one lab at Ohio State that epitomizes our engineering plus medicine superpower, it's the M4 Lab. Megan, how did the medical modeling, materials, and manufacturing lab come about?
It's going to be a long day of saying that. Our M4 Lab is a collaboration between the College of Engineering Center for Design and Manufacturing Excellence, or CDME, and the College of Medicine, and in particular the Department of Otolaryngology. CDME's overarching mission is to advance manufacturing technology and the workforce to meet the nation's needs, and so within there, M4 covers medical. CDME had been helping partners innovate medical devices for several years prior, but it wasn't until our clinical director, Dr. Kyle Van Koevering, made the smart decision to move here from that school up north about 3 years ago. And that's when the M4 name and activity really took off. He took a tour of CDME's manufacturing facility and had the idea to take what the center was doing in other areas and apply that to engineering for personalized care of patients using 3D printing. Dr. Van Koevering is head and neck cancer surgeon here at the James, and it's the close partnership that allows our lab to break down traditional barriers between engineers designing and building in a lab and clinicians treating patients at the bedside. Some of the most immediately impactful work we do in M4 uses what we call point-of-care manufacturing, where within the hospital system, clinicians with engineering support can provide solutions for patients that otherwise are left without options. This takes the form in a couple different workflows. And you probably know our James Cancer Hospitals see some of the most complex cancer cases, so we can help our clinicians better visualize, plan, and execute a surgery using computer-aided design, or CAD, and 3D printing of anatomical models.
So I will say I'm glad you didn't use that bad M word from that place up north.
Yes.
But you did mention patients. And you mentioned that the lab's primary efforts aim to benefit patients undergoing new, uncommon, or complex surgeries at The Ohio State Wexner Medical Center by providing access to 3D anatomic models. So can you give us a couple of examples?
Sure. It's kind of the bread and butter of what the M4 Lab does. We do a lot of this work within head and neck cancer surgery. So for example, a more frequent than you would hope scenario is a patient comes in with a tumor in their jaw. The standard of care here at the James is to remove the tumor and replace the missing bone with a portion of bone elsewhere in that patient's body. Using the patient's own scan data from a CT or an MRI, the M4 Lab can create a digital file of the anatomy of interest, and then we can 3D print that to recreate the scan in physical form and deliver that to the OR. For cases where there are important landmarks or anatomy nearby, we can create full color prints depicting bone, tumor, vessels, nerves, whatever the surgeon needs to best prepare and execute the procedure. The surgeons use these models in a variety of ways. They can use them as a visual guide, as a rigid template to bend a reconstruction plate. One of the most fascinating ways I've seen them in a communication tool between two teams. So for context, these complex procedures typically operate with two groups. We have one group of surgeons up at the top of the patient removing a tumor. Meanwhile, another team is preparing the reconstruction bone to be taken elsewhere, sometimes in the leg or the shoulder blade. The way the 3D printed model is used as sort of a home base of communication between the two teams so that they understand the patient's specific anatomy, the size and location of the defect and the implant that they're preparing. And it's really amazing to see them going back and forth. We recently helped an orthopedic and plastic reconstructive team on a case for a patient who was having issues of non-union in their bone. We were again able to take that patient's scan and meet with their surgeons beforehand to understand and develop the plan. They determined where they were going to remove the old bone, how much donor bone they were going to take, and how best to lay out that bone to reconstruct. And we were able to digitally execute that surgery for them beforehand and print guides to use in the operating room so that they knew the cuts and the insets they were making were exactly to the plan. The surgeons told us it normally takes them 1 to 2 hours to do that portion of the procedure, and with our support, they got it done in 8 minutes. They also completed imaging after the procedure and said reconstruction had better alignment than they ever see. These time savings are important for the patient as they're not under anesthesia long, and important for our surgeons and their staff who are in the operating room for long hours. It's this work that's really impactful for us to be a part of.
These are definitely impactful examples. And I love the fact that we are showing this synergy between engineering and medicine. So when you think about these examples, there is a primary effort, which you've talked about with your examples, but there's always secondary efforts when you think about innovation and involving innovators. So what are other exciting projects that M4 is targeting or maybe already involved in?
Yeah, we have a lot going on. Our team is small but mighty, and we cover a lot of ground. We also use 3D printing in our lab to provide patient-specific prosthetic devices to help bring patients to a new normal. And we help create clinical skills simulators that can be used to train rising medical professionals. In addition to this really tailored patient-specific work that we leverage 3D printing for, we also help innovators here at OSU develop their own ideas. So we have a team in our group focused on medical device development. They interface with clinicians and faculty who have a device idea on how to better treat a condition or execute a procedure. And then we provide them the engineering support in the early phases to see their technology move forward.
So with this small and mighty team, which is very, very mighty, there's another M, tell me a little bit more about the lab's vision for fostering the medical device innovation ecosystem.
Yeah, back to what I just mentioned with our development work, the innovators, especially clinicians, they know firsthand the challenges in treating patients. They understand the clinical need and how improvements to medicine can be made. What we know is that for many faculty and clinicians, they're not wanting to quit their day jobs. So right now we have a group of folks with great ideas, but they can die on the vine if the infrastructure isn't there to kind of lower the barrier of technology advancement. It's a big startup time in that and time away from their practice or academic duties. So what we're envisioning is a streamlined pathway for someone with an idea to enter into and get the engineering, commercialization, regulatory, quality, and funding support in order to translate their bedside idea to market. We have collaborators across the university, some at Keenan Center, some at the Drug Development Institute, and statewide partners who share this vision for an ecosystem that shares the strengths of OSU and our other partners to de-risk ideas and get a higher and faster throughput of innovation.
So you mentioned faculty and clinicians, but this lab sounds like an ideal environment for engaging students in experiential learning. And I'm sure it's happened. Can you talk a little bit about that?
Yeah, I mentioned the small but mighty team. We're actually about 6 staff deep, and we have a roster of 15 undergraduate students currently. It ebbs and flows based on the project work, but really it's a key point in our lab and in the CDME as well, is to make sure that we're developing a workforce along with this technology. And it's in addition to the patient impact, the other part of that is kind of the most impactful part of the work we do. So our current student makeup makes up about 6 different majors. We have students from biomedical engineering, mechanical engineering, aerospace, industrial systems, industrial design, health sciences, quite a mix of students that we really pull their strengths together on projects. These students get hands-on experience at every part of the clinical and device development workflows. So students experience manufacturing these devices, delivering them to the clinic, and then seeing their work being used to help real patients. Our clinical work operates under a quality management system, so they get exposure to the governance and requirements they'll experience should they choose to go into industry after graduation. And like I said, beyond helping patients, for me, the student involvement is an impactful work that really keeps me going.
Okay, so we have faculty, we have clinicians, we have students, we have patients. So you've talked a bit about how M4 works with university and the hospital system. Now, with this innovation ecosystem, can you talk about how M4 collaborates with industry partners?
Sure. So we do a lot of work internal to the university, and they keep us pretty busy, but we do have external collaborators for more of our project-based work. We are a part of a recently awarded Rehabilitation Engineering Research Center, or an RERC, and that's with Willowwood, an Ohio-based prosthetic manufacturer. And we're working with them on strategies to improve the device and human interface for prosthetics and orthotics. For our project specifically within that RERC, we're looking to innovate around prosthetic socket design. And this is with our industry partners. And so we have a background in patient-specific design of devices. We have industrial manufacturing equipment. We have a workforce that is trained in this as well. And our industry partners really provide the experience of a commercial manufacturer and working with the user group who will be using these medical devices.
So earlier on, you mentioned and you gave some examples of projects that M4 was involved in. And one, for example, you talked about orthopedic reconstruction. So if you think about similar modeling and 3D printing for simulation training for medical professionals, how is this work different than traditional skills training?
Yeah. The traditional model in medical education is usually coined see one, do one, teach one. There are other options available through cadaver labs or some expensive, somewhat low fidelity mannequins or simulators to get training medical professionals some reps in before they get to a live scenario. Those often lack the pathological realism of a disease or an injury state. So using computer-aided design and a variety of manufacturing techniques, we can create simulation trainers that have defects such as a cerebral spinal fluid leak or a carotid blowout or a tracheostomy patient so that training practitioners can practice repairing an injury or establishing an airway before they ever see their first patient.
So I love hearing about the convergence of engineering and medicine at Ohio State. The M4 Lab is yet another example of how brilliant Buckeyes are collaborating to improve and save lives. Megan, thank you so much for joining me.
Thank you again for having me and letting me share about our team and the impact we can have.
Thanks for listening to Enginuity. Stay up to date on all the amazing innovation and groundbreaking research happening within The Ohio State University College of Engineering by connecting with us on X, Facebook, Instagram, and Threads at OSU Engineering.